Like that is count.
Yourself.
Yes, exactly. You all will be sitting here.
Practice run.
Yeah. Like,
A little bit.
hello. More. Good evening. Come on in.
We're trying to pile up on that side.
Okay.
If it gets too cozy, feel free to spread out. These pillars are part of the.
They're one of the features, not a bug.
Oh,
Yeah.
And if the presenter is having a rough time, apparently, they can go hide on the other side.
All right, and we do have audio working now. Sorry if anybody's online, but thank you all for coming to the Louisville Azure Meetup group. I appreciate it. Today we have an honored guest, Jes Schultz. Hopefully I said that right. Talking about which database options to choose within Azure. So, please.
Okay, so thank you everyone here and online. So awesome. It's a wonderfully lovely day outside after a few rainy days. So thank you for taking the time to hang out with me. Yes, so I am talking tonight about which Azure database option to choose. I think my Kirkland signature batteries on my presentation must have run out, probably because it's been sitting here since. Yeah, it doesn't get used as much as it used to. Oh, there we go. Maybe. Hold on. I actually have to be on the presentation. There we go. So for those of you who have not met yet, I am a Microsoft data and AI cloud solution architect. So I've worked with SQL Server for going on 20 years now. My area of expertise in particular, transactional database with Azure SQL, Postgres, little MySQL, but also work with the whole Azure data platform. I'm based right here in Louisville, Kentucky, about 3 years ago. I do run the Louisville data meetup group. So we meet on the second Thursday of the month. We meet over more on the east side of town and are looking at balancing between that and another spot later this year. But yeah, if you're interested, we're also a meetup group. If you have people that work with data, we've had a large assortment of topics. Today, Jeff presented on the JSON operators in SQL. We talked about the new Microsoft Fabric. We've had presentations on Postgres for SQL DBAs. So we cover a lot of different topics about the work. Also, if you want to get connected with me, I am on Twitter and Blue Sky as Rosie. Please connect with me on LinkedIn. I post on there a lot more now. And also, I have a GitHub repo. My GitHub repo is where I keep all my presentation slides, scripts, demos, a couple cool things I've built for Azure SQL. So if you GitHub it.
Including the data meetup?
So the data meetup is also the second Thursday of the month, but we meet at lunchtime.
Okay.
So I've actually had a very busy day. I spent at 9 o'clock this morning, I presented for University of Wisconsin Oshkosh students who were one of my former managers is a adjunct professor there who wanted me to talk about speaking in the cloud. And then I went to the Azure or data meetup group, worked for a couple hours. And here I'm like, oh, it's a busy day. I don't know where I am or where I'm going to be. So yes, what we are talking about today, just again, kind of reinforcing IaaS versus PaaS in the cloud, and focusing on PaaS offerings here. I'm really not going to talk to any degree about running any databases in any virtual machines because I think that's not what we're here for. I'll talk about the different specifically the OLTP database offering. I could talk also for an equal and possibly longer amount of time about Synapse Analytics, Spark Pool, Databricks, the Fabric stuff, but that's a conversation for another time. We'll talk kind of about what highlights each, and last but not least, that whole platform as a service, like what part of those are managed for you with all of these offerings. So infrastructure as a service. That's when you just basically get the VM, you manage the operating system, you manage the networking, you manage the database, you do all the upgrades, you do all the backups, et cetera, et cetera. You can run SQL on a VM in Azure as I have. You can do that in on premises, you can do that in AWS, you can do that in GCP. yes, there are some benefits to running SQL on a VM on Azure, like you can schedule updates, you can take the backup, you can schedule the backups to go directly into Azure storage, but again, all something that you're going to be managing. Obviously, comparing and contrasting that to PaaS or platform as a service, right? We are giving you the entire database, or in the case of managing the Postgres, the entire instance, the entire server as an offering where we're managing hardware, operating systems, SQL database version, upgrades, backups, high availability, and more. So we're focusing on the PaaS side of all of that. And also, if anyone has questions at any point in time, please ask. I much prefer to talk with people rather than at people. And if there are any questions on that. So again, when I think about data, I primarily think of relational databases, non-relational databases, and in-memory databases. Relational is going to be your highly structured data, right? You have relationships between things. You have customers who place orders, and the orders come from suppliers, and the suppliers send you invoices, and all of these things are very highly related. Contrasting that with non-relational NoSQL databases, right? That's where we have loosely structured data, semi-structured or unstructured data. We might have combinations of different types of data, text, images, videos, all of that kind of coming together. And then we also may need in memory, right? So these are very ultra low latency in-memory data storage for the fastest access. And when you go into look at creating a database in Azure, you are presented with all of those options, right? So how do you pick? Where do you start? Which one's which? Where do you go from there? So I start by just kind of lumping them into those basic categories, right? So for our relational databases, obviously we have the SQL Server products under Azure SQL brand. There's also Azure Database for Postgres and Azure Database for MySQL. And there is also a Postgres offering that is stuck inside of Cosmos DB as an API, and we'll talk about what that is and why. For the non-relational, right, the flagship product there as a PaaS offering is going to be Cosmos DB. But then you get into Cosmos DB, and there are 6 different APIs to choose from, and why, right? Like, what are developers using them for? What's going to be best suited to use? When it comes to in-memory, we offer Redis, so Azure Cache for Redis as a platform as a service offering. So instead of having to run it, interview, and manage a lot of things, we're actually giving you that as a PaaS offering. Correct. So Synapse and Analytics not mentioned here because while they are a database and they use SQL, structured query language, we're doing star schemas there. That's analytics. Again, query language. Could definitely talk about that for our schema there. So let's start with a little bit of a dive into the different relational databases. And for the ease of use, I am going to be comparing all of these different database offerings to what type of card. Everyone can understand that when I say we're using Azure SQL, we're using a Formula 1 card in Azure. Why do I say that? Well, when you get a Formula 1 card, it's expensive, absolutely. I am not denying that. Even as a Microsoft CSA, it's the expensive part. It comes with the latest and greatest engine that's always up to date. It's going to come with full-on support, right? You think in terms of a pit crew. Your tire gets blown, you just pull off and you have somebody fix it. It also is going to have the latest and the greatest in terms of performance and security and fixes. So yes, you get all of that at a price. But that's really it is Microsoft's flagship database engine. And here's a comparison. AWS. They have RDS, right? The relational database service. When you go into AWS RDS, when you pick SQL Server, you still have to pick a version, right? You have to pick, I want SQL 2017, I want 2019, I want 2022. Same thing in GCP, when you go to create a cloud SQL database, you still have to pick a version. And they'll upgrade within that version, but if you want to migrate to a higher version at a later point in time, it's still a database upgrade. Whereas with Azure SQL, like Azure SQL Managed Instance and Azure SQL Database, you never, ever have to do an upgrade again. Having been a DBA, having been a consultant for many years, having worked migrations of everything from SQL 2000 up to SQL 2022, that's game changing, right? So much can go wrong in an upgrade. There's so much that has to be tested. Performance can regress. You've got your logons to migrate. So like that's one of the biggest benefits of Azure SQL as a PaaS offering. Evergreen engine, never have to do another DB. Again, you're getting all of the performance, all of the security options, all of the support options. And as our SQL Service Engine is truly differentiating itself with security. We still have column level encryption, transparent data encryption, so at rest, enabled by default on every new database. TLS, so using SSL is mandatory. Like you cannot turn that off for database and column connections. We offer always encrypted. So the always encrypted feature is even a step beyond just encrypting the data with TDE at the database level. Always encrypted, the master encryption key rests in the app service and the app server. So the data is encrypted and sent across to the database and stored there encrypted and then sent back encrypted. Which means that even if you have a DBA who has FA admin level rights to everything, if they should not see that data, they will not see that data. So that's available not just with SQL Server on-prem or in VM. You can also hook up to a SQL database or a SQL managed instance. There's server level and database level auditing. We also offer Ledger, both Ledger databases and Ledger tables for making sure that you, it's essentially blockchain, that's all I'll say. But it allows for that constant tracking of every single change to be written into an independent register so that you can verify if any data changes have been made, when, and by whom. So SQL, like Azure SQL differentiates itself, I think, with those high-level security features, which are truly designed for enterprise. And also, right, other features that have been introduced in the last few versions of SQL Server on-prem are also query store, column store indexing, in-memory OLTP. Most of the time, because it's a lot easier to ship something into a cloud service that runs in your own data centers, features come to Azure SQL. And then eventually, when the next version of SQL Server gets released, they get added there. So if you want the latest and greatest, Azure SQL is great. Different flavors of it, right? So you might see managed instance, you might see SQL database, you might see an elastic pool. Without going into, I have an entire hour-long presentation that I give to customers on just how to pick which one of those. But long story short, managed instance is the closest thing you will have to a full SQL Server instance, right? So you set up a server, you can have one to many databases on it. We're actually currently it's at about 100, but we just previewed a new next gen that will allow you to have up to 500 databases on a managed instance, which is a significant, right? Like being able to put a lot more resources on one. It runs everything like SQL Server Agent and Service Broker and all of those kind of instance level features. And so it's a great opportunity to lift and shift anything you have on-prem or in another cloud into. Also, a little bit more expensive and a complete pain in the you-know-what when it comes to setting up the networking, because you have to have a VNet and a subnet for this and a subnet for that and correct addressing spaces. So it's work, but you get that full compatibility versus Azure SQL Database, which gives you a database. Here are your 4 V cores with their 16 gig of RAM and your 4 terabytes of storage for that database. That database managed all by itself. That database doesn't talk to anything else except for that. An elastic pool, pooling, single database resources. Lots of companies that are like SaaS providers, ISV providers, will use those. Group 100 or 500 databases in a pool just to kind of conserve resources, especially if they have highly variable. So why should developers use Azure SQL in particular? We have spent a lot of time building some really good performance tuning tools into the SQL options in Azure in particular. We introduced Query Store. So while it debuted in SQL Server 2016, Query Store has been in Azure SQL since about 2014. It's been around a long time. It's turned on by default, baked in, and it drives some other tools we have out in Azure, like performance insights and query performance dashboards that are baked into the portal. There's tools that easily allow a developer or a DBA or an analyst to like go into the database and go, why is this so slow, right? What are my top 5 queries? Like, is it CPU? Is it IO? That's all baked in. We have automatic tuning, which helps with things like index management and plan management. Intelligent query processing and HPCs and SQL just baked into the actual database engine itself to make things faster. But we've been adding those features on for the last 5 to 6 years under that umbrella. One question I get asked a lot is there some sort of offline development option, right? Because Azure SQL is expensive. And if you're supposed to give every single developer in your org access to their own database, right? Like that's what I would do on-prem. Every developer would have SQL Server Developer Edition, develop their changes, check them into Git or whatever. A little more expensive to do that in Azure SQL. Yes, there's like dev test editions and you can get some pricing for it, but also we do have an offline emulator available for it, so you can download that. Azure SQL tightly integrated with Azure Functions, which makes it very easy for developers. And last but not least, one of the coolest things I think that's come out, not just for Azure SQL, this is actually something you'll hear me talk about with almost all of these databases, is what we call the Data API Builder. Right, so developers, especially in the last, I would say 5 years in particular, have like very API driven. Right? They're writing their get statements, their update statements, they're posting things. And then you get to a database and you can't just do that, right? Like all of a sudden you have to learn this other language. You have to learn how to write select statements. The DBA tells me I can't just write select star and everything and filter it down in my application. That's given rise to a lot of different tools, right? We think entity framework, other ORMs. Data API Builder is a new tool that lets a developer simply query their database in Azure using a REST endpoint or a GraphQL endpoint. Same tools they use currently, same language they use currently. They just say, get data name. They can put things to change things. So it's kind of a revolutionary way for developers to interact with databases.
Is it only for local development?
No, the Data API Builder is for everything. Yep, that actually
They have emulators to allow local operation. Is that what that means?
Could I connect the Data API Builder to the local emulator?
I'm listening. Local.
Oh, yeah, this is the DB emulator for local development. Guess what? What a laser pointer. Yeah, so the SQL DB emulator for local development truly can be run locally. So it actually downloads the Azure SQL bits into a container. You have to have like Docker running, like the developer has Docker.
Called when it points out.
Yes. And then, again, when you're developing that one thing, but the actual production application reports to the endpoint in Azure. So that's kind of my feel about everything.
How's the,
That's a great question that I don't know all the details. Yes.
sure,
Yes.
terrifying.
Oh my gosh, yeah, they would not have the adoption it has right now, and some of the customers that have done like use cases, if it was not. So then, let's compare that Azure SQL with Postgres. So yes, you could take Postgres and you could run it on a virtual machine in Azure. Or you could spin up an Azure database for Postgres flexible. So there's an older offering called Postgres single server. Don't use that. It's being deprecated. Lots of features. So a couple of years ago, we were just what they call flexible servers model. This is the way. So I consider Postgres the Honda Civic of the database world. It's been around forever. It's wonderfully reliable, works for almost everyone in most situations, and there's a lot of different trim models, customization models. That fits Postgres, that fits the Honda Civic. So Postgres is an open source database. Microsoft pulls directly out of the community edition fork. This is not in any way, shape, or form customized Microsoft build. Within the Azure Database for Postgres engineering group, there are Microsoft engineers who are major committers to Postgres work. So Microsoft actually works fairly closely with Postgres. The benefit of that is when a new Postgres version is released, like I think 16 just dropped within the last few months, Microsoft usually gets that available in Azure prior to like AWS or GCP access to it. It's a nice reciprocal relationship. Right now, versions 11 through 16 are supported. Postgres allows you to manage a lot of things to server level parameters. That's where you fine tune a lot of things. Running even this PaaS offering, you're not going to have every single one of them, but some file system level parameters are grayed out, but you still have access to most of your configurable server parameters. If you're using Postgres for anything that requires scaling out, at the back end for a web app, or you want to run some, what are they calling it these days? The HTAP model, right? Where you have your OLTP database, but you also have some analytics or some reporting reading off of it. You can scale out to 5 read replicas per primary Postgres server. And that's the nice thing about running this, again, as a platform offering is, you just say spin up a replica. You don't have to create another virtual machine. You don't have to create the connections. You don't have to set up the Postgres replication. I've done that a couple times, and I was like, oh, SQL Server does this so much better. Like, I didn't even like SQL Server replication, but then I got into Postgres replication and thought, ooh. So the other big thing about Postgres that I love and that it's such a big draw for developers in particular is this concept of extensions. So extensions are, again, another open source piece where anyone can write an extension to give the database additional functionality. There are hundreds of Postgres extensions. A lot of them are just automatically available. All you have to do is check a box to say, like, add this extension to my Postgres flexible server. Some of the most popular that I have worked with customers on include timescale DB. So it allows you to natively put your time series data in Postgres.
So you said they're when you click to add them, is that through, or is it, do I have to download a module and somehow?
You don't have to download a module and install it in anything. That is fully managed. If we offer the extension for that version of Postgres, it is the current version of the extension for that version of Postgres, and you don't have to install anything. Yep, that's what's there.
And does it all work with like private endpoints, and if we're in a secure environment where nothing can get? Thanks.
Yep, and actually, private, I want to say private link for Postgres flexible server just went GA.
Okay.
So that's fully available, fully supported private link for this service. So you can have fully secure communications.
And the Azure the reason I was asking is I saw Azure AI up there
Oh,
and
yeah.
PG Vector.
Yeah. So, right, common things we've had for a long time, PostGIS, right, for spatial data, PG audit, PG cron for scheduling, PG stat statements, which actually we use to build another query store tool. But yes, the big one is recently, right, like the last year, AI has exploded. As a data person in particular, right, my entire life revolves around how do we get this data into our AI model, or conversely, how do we have some form of AI churning through this vast amount of data we have to actually make sense of it. So there are two extensions for Postgres that are very closely tied to AI. So number one is called Azure AI. And what that does is allow you to, from your Azure Postgres Flex Server databases, make calls directly to the Azure AI services. So the Azure AI cognitive services, the language service, the voice services, or the open AI service.
That egress traffic to Azure AI go over a private VNet as like a VNet integration, or is it in Microsoft and goes out to the internet?
No, this is all stuff that is entirely within Azure.
Yeah, I know, but so all of the policies where I work are nothing can hit a public endpoint. If a public IP address, it gets blocked.
Yeah.
And you create these private endpoints, but private endpoints are one-way streets in. They're not the street out. So a resource to connect to another resource has to have a way into your VNet. And I didn't know if Postgres had one of those or not.
Remember, this is Postgres running on Azure infrastructure.
Yeah.
So everything Azure infrastructure is 100% on the Azure backbone for private communication.
Yeah.
So because this is, so Microsoft set this up. This is in a virtual network we and subnets we have produced content we have owned and managed. Right? This is not Postgres running on a VM in which it could possibly go outside of the Microsoft backbone. This is 100% Azure services talking to each other.
Yeah. Well, so the problem is that they literally flip that switch that says no public access, including Microsoft services. So the only way in is through that private link endpoint or VNet integration.
I don't know, I don't know the fine,
Yeah.
the fine details of Postgres connecting to OpenAI. But if you have questions about that, shoot me an email. I'm happy to look into it.
I actually don't need that piece of it. It was really the vector store, because that was going to be my question. If you have vector store coming up, I'll wait. But
So yeah, so we also support as of now. So the Azure AI extension pool, like some people are using it, the PG vector extension is the bigger deal, right? That's what everybody wants right now. It's an extension that allows you to store your vectors that hold your tokenization, arrays, etc., for your LLMs if you have built your own into a Postgres database. That's a big deal. It's a big deal because instead of having, there are very specific vector databases. Like there are companies that just do that. But now you have another entire vendor to work with. Now you have another database that your data admins have to learn, and another database that your developers have to learn. The PG vector extension lets you use your Postgres server as that database, and your developers use their already existing people knowledge to query it. And that's part of the managed service, right? So this is not something where, again, you have to spin up a VM. It's a point flexibility. So yes, that's a pretty That usage on that has just like interest on that, even on my Twitter timeline has been like, wing, in the last 3 to 6 months.
Microsoft's offerings for vector as stores are nice, but they're $1,000 entry point per month, regardless of which one you choose, either AI search or whether you choose MongoDB, or sorry, and actually Mongo, I haven't checked. Redis cache.
Okay, there's a Redis cache, so there is also, I believe, like a Mongo extension that allows you. Yeah, so no, this is absolutely a huge deal.
Yeah.
In that the PG vector extension exists and works with Postgres open source in Azure as a service. So something to definitely take a look at. Right.
That could also be private. That can't be private.
Azure AS, that's why it's so expensive. You have to go all the way up to an S2 SKU of Azure AS search to get privatized vectorization. You can get vectorization at basic if you're doing things over the internet. But as soon as you say internet's turned off, everything has to go in your VNet only.
Because they know it's a Fortune 500 company that's going to ask for it. So,
And then
roll out the dump truck.
But this would be a budget offering, which the only other budget offering are self-hosted like Milvis or.
Yeah, I have not built my own LLM and put all this stuff in it myself. I've talked to customers that have again talked to, like, I know that a few of the PMs and Postgres for having a product group, so they are seeing it's really hot and hiring like mad and investing funds to keep up with this. And everything, so that's the end of some further than that. But yeah, like if you need more resources on that, if you have questions, email me.
Yeah.
If you learn anything really interesting about it, also please let me know. So yeah, Postgres. It's the most popular database out there, right? Like Stack Overflow developer survey, plus just my overall extensive knowledge of IT says people love Postgres. Again, it's the Honda Civic. It's totally reliable. And here we are. So the lesson that I'm adding this year is those 2 additional exceptions. So again, why Postgres developers, why are they choosing? Again, Stack Overflow developer survey has said the last few years, like Postgres most used by everyone from loan developers to enterprise companies. So we are trying to build things to make that better for all of these developers that use it. So one of the cool features, like I said about Azure SQL, was that query store feature. For those of you that are not familiar, one of the problems we have had historically as data admins and developers and performance tuners was the app developer would call the DBA in the morning and say, hey, what did you change? My app was running fine yesterday, it's running great yesterday, it sucks this morning. The DBA says, I didn't do anything. Literally nothing has changed. What did you change in your code? And the app dev says, absolutely nothing. 90% of the time it's caused by, things like statistics were updated, or, somebody wrote a new variation of a query with something different in the where clause, use this different plan. But there is no way to track that because inside of database engine, they keep the most recent version of the So in that SQL Server engine, and again, it started in Azure SQL and then was introduced for SQL Server 2016, is called Query Store. And it keeps a historical record of query plans over time. And there's some cleanup options available. It is essentially like a black box recorder of everything that's happened in your database over time. I remember when I first started at Microsoft, I was working with a major insurance company. They were upgrading from 2014 to 2016. Or maybe it was 2012 to 2016. No one upgraded from 2014 to 2016. Things are out of support. DBA team is just like, I don't understand, like, why would I turn on query store? I'm like, just do it. Like, there's one database. We're going to start with one database at a time, something that's pretty low key. And the first time they actually had to use it, I was actually on site with them. And they were like, oh, we're getting all these performance issues. I was like, this is the moment we've been waiting for. Like, this is the time to go to your query store dashboard and look at it. And it worked, right? They were like, oh, there's the query. Oh, yep. It was very different yesterday. I can pin yesterday's query plan and make it use that and sort of figure out what happened with the parameter specification. And then it fixes stuff. So downside is we go back into the SQL Server engine. Postgres doesn't have that. But Postgres has that for runtime stats like extension in it. You also have one-time stats statistics built into the Postgres engine. So in Azure Database for Postgres, we built a version of Query Store. And it gives you that same historical insight into your queries, right? What something was running fine yesterday, not so fine today. Performance tanked an hour ago, we swear we didn't change anything. It enables you to use these tools inside of Azure, the Query Store, the Query Performance Insight, to help identify performance issues much more quickly and so on. So I think, again, Query Store in SQL Server and the long-time SQL person was a game changer. And if I talk to customers that are not using it these days, I'm like, you've been missing the boat for 8 years now. So having that available, a flavor of it available for an open source database, also pretty cool. Again, that data API builder that I talked about works just the same with Postgres, right? You're going to again, point your app to your database and create either a REST endpoint or a GraphQL endpoint, send your API calls rather than having to write SQL statements for everything. So there, and again, the integration with OpenAI, the ability to sort of vector data in Postgres, it just keeps going. So then we're going to talk about MySQL. Still around. MySQL is the geometro of the database world. I think I actually had a friend in high school who literally had this color like this.
That's where Maria being right there. No.
I actually like refer to it as the geometro because remember back in it was like 2011, Oracle bought MySQL, like bought their rights to own MySQL, like it came over there. And that's like when Chevy bought the Metro from Geo. Like people that love their geometry were very excited about it. MySQL has been around forever, right? It is part of the traditional landscape with Linux, Apache, MySQL, PHP, for them. My very first consulting job ever was a marketing company, and they built websites for customers. They hired me as their first database person. And then I learned that they used MySQL because they didn't know to ask me, like, what databases do you use? And I didn't think that them, like, what sort of database are you using? And I had this huge crash course in MySQL. Yeah, MySQL is another open source database. Microsoft pulled directly from the MySQL community edition. So it's not a specialized fork. There's nothing special about it. You mentioned MariaDB, which after Oracle purchased the rights to MySQL, they community forked it again and created MariaDB, which is truly open source. For a minute, there was a MariaDB, like Azure database for MariaDB platform as a service offering. But as of like December or January, I heard that was being deprecated next year after. So it was there for a minute and now. So again, some of the good things like MySQL runs particularly websites. So again, with server parameters, which is what you use to configure it, because it's a platform offering, some of those are unavailable because they might like interface with the file system or the operating system. But outside of that, anything performance related, you still have full ability to configure. Data in and data out replication is a big feature of MySQL, right? Being able to chain all these systems together. We support data in and data out from on-premises, from other MySQL in Azure, whether that's in a VM or in another hosted offering. We also support data in and data out from other cloud providers. So if you use that in your systems as a pretty old, then we're going to use and again, website, read website, scale out. This service, this managed service offering, offers up to 10 free websites for scale.
WordPress didn't exist.
Yeah, right. Exactly. That and like maybe 2 content management systems, maybe like 2 CMSs.
But WordPress keeps it alive.
I haven't worked.
Did you figure that out?
I don't know, but I'd like to figure out how to kill it.
MySQL.
It runs like 71% of the web.
It runs some stupid amount of the web.
MySQL's corporate website that keeps it alive.
It's a mess, but everybody's had a time with it.
Think about like every time
It just kind
a
of
small
works.
business goes to a GoDaddy or a domain hoster and says like, yes, create me, I want to get my domain name and also create me a database. And they're like,
It's $10 a month more for Postgres. I'm going with MySQL.
exactly.
Every marketing company we encounter.
Yeah.
It's very, very, very few who do something like that. Handful of something.
Oh, no, it's a great thing.
I do enjoy hating on
No,
it.
that's what it's used for. It really is.
They have a website that just lets you manage MySQL from a website. There's the whole thing, creating tables, whatever. It's like, so a developer loves it.
No extra tools you have to learn. So a couple of things to note about the Azure Database for MySQL Flexible Service. So again, that managed. MySQL has, I think, 5 or 7 different storage venues. The 2 that are supported in the platform as a service are the DB, which is closest to like a SQL server or MySQL with the form the primary key relationships for indexing capabilities, that sort of thing, and memory, which supports in-memory. Again, not quite the query store tool, but MySQL for capturing historical records of queries has something called the slow query log. So this is one of those server level parameters that can be enabled. So we enable that slow query log by default with this, and then that feeds into the query store that we create for the service and feeds into that query performance inside. So you'll see any of these 3 major relational database offerings, so SQL, so Azure SQL, Postgres, and MySQL, all of them will interact with one and have this query performance insight tool, which is truly meant for that, query store, historical data, let's review the last 1 hour, last 24 hours, last week, like custom date ranges in the last 30 days. Just to really, again, especially for companies that don't have like highly specialized DBA teams that know all of the perfect tuning tips and tricks for all of the major database engines, it can be a really helpful addition to the developer. And again, we're doing that API builder can absolutely work with the MySQL. Yeah. All right. Oh my gosh, we're talking about SQL. We don't offer that as a service, right?
What's the law of geometry?
Someone recently, after I gave this, someone was like, what's cool? And I was like, oh, that's a little service. You have to pay your driver, like you have to take it to a special garage. Your insurance bill's probably ridiculous. Like, I just want to
Yes.
It's a great analogy.
Yeah.
You make notes for yourself to dab, but yet you haven't done it yet.
I'll do a lot of things to embarrass myself in front of other human beings, but any sort of dance move is absolutely. But if you'd like to demo. All right, so those are the three big relational DBs. Any other questions before we move on to non-relational? So no SQL. So now we're about to talk about the Tesla of databases. And it's really what I consider Cosmos DB, right? When you're comparing what people were used to for so long with relational databases and how those engines worked to now going into NoSQL, document databases, and key value pairs. Like I honestly compare it to going from driving a car to a Tesla. Right? Like I drove a Tesla for the first time last summer. I had a rental car for a week. That was weird. All of a sudden, you're driving along, you take your foot off the accelerator, you call it the gas pedal, and like it just kind of stops, right? And you're like, oh, I don't feel great. Like it just right? But it's a very different experience, right? No oil changes anymore. Like better being charged. So Cosmos DB compared to relational databases is a Tesla, just a very different function. So Cosmos was built specifically for the cloud. Right. This is not a product that Microsoft offers on premises. This is not something that we ship out to other companies as like an offering in their cloud. It is a globally distributed, elastic scale like data layer. So under the hood, what Cosmos DB is a lot of storage. And there are physically partitioned pieces of storage, and then there are logically partitioned. And really all Cosmos is doing is translating where those vast volumes of unstructured data that you have are in relation to what data you're having to use. That's the whole magic of Cosmos DB. And because it's just storage, it exists, it is a tier 1 service that exists in every single Azure data center worldwide. And it's
Put your data there and charge you for it if you aren't careful.
correct, right? Global scale, be very careful when you choose. And then the other thing is not only is the data available in all of the regions, but depending on the consistency level that you choose, right? We have everything from super strong consistency to eventually it shows up. On those looser ends of the spectrum, this is a true like multi-light database offering. So unlike a SQL server or a Postgres, where in order to get multi-master right, you have to have some ridiculous merge or peer-to-peer replication with sync agents and merge conflicts and all of that. If you choose one of the lower bounded consistencies in Cosmos DB, you write your data in from anywhere in the world, and eventually the Cosmos DB service will just sync it up and offer it up to you, and you don't have to write any sort of conflict resolution whatsoever. So all of the different APIs that I'm going to talk about have these same capabilities. The thing is, when you go into Cosmos DB, like it's not just one database, right? The first thing it presents you with is which API do you want. You want NoSQL, Mongo, Cassandra, Table, Gremlin, or why are we offering Postgres? What is going on? So let's talk about what each of these do. So NoSQL. That is what you would think of as a typical just JSON document storage data store. So JSON is great. I would use this analogy of we used to get like the series of JC code. When I was a kid, people excited one always came like right before school time. So you always like do your clothes school shopping there. Now imagine trying to take all of that data and put it into a relational database. Right? Toys have a color and a size, but shoes have children and men and women, and then they UK sizing and then they US sizing. Pants have a waist and a length, whereas shirt might just have a size, but if one's dress shirt and also the neck size and a length. Like, how can you possibly design a relational database schema for the thousands or hundreds of thousands of objects that are in a cache? You don't. You put it in a JSON file. Flexible schema. This level says apparel, and this level says toys. Can't just go to the presentation how you do that JSON. So if I have any questions about this, I'll just fact check by looking at them. Yeah, your apparel type, your apparel section, your shoe section, your toy section. Under that, you can kind of group men's, women's, or shirts and pants, and each of them can have all of these individual properties that don't overlap. And then you can still index it, right? You can still query it. JSON has really become the language of the web, right? Like a lot of things nowadays. One of the best things about JSON and the document storage in Cosmos DB is it's called MySQL, but just what you use to create SQL. It's a flavor of special query. With this, again, automatic indexing is built in, so it does index up to the first 2 levels of your document. Again, data API builder, we keep talking about.
That's the, okay.
Yes.
The first one plus the next one. Okay, hold on.
Yeah, and then it does automatically. One of the downfalls to NoSQL API with Cosmos DB is, especially when people building and designing are coming from the relational database background, if you have to have your partitions. Like I said, all the data underlying it is 100% partition, physical, logical. And it's a very different concept of how you partition in a NoSQL world than it is from partitioning in Oracle or Postgres for performance and data loading. And so you really have to think about when you're building your JSON document and you're building a partition key, what you're thinking about is, how do I want, like, when I query this data, like, what results am I looking to get? Like, how do I want this data to play out? That's your partition. And then you should build all of your data around what question am I trying to answer when I query this data. And we have tools out there like there's an index advisor and there's a partition key advisor that both of them are available for Cosmos DB NoSQL. So over time, we've learned the hard way what questions people have about using this and have tried to build some tools that way. Again, this also offers an offline emulator so that you can download. It's only for the NoSQL API, but you can download that and then run it on your desktop so developers can get them locally, test out different partition, key structures. When you run a query, it will even tell you so. And the pricing for Cosmos DB is based on RUs, request units, basically how much data are you returning every time you query it. So the offline emulator will even estimate based on the data size you have, the partitions you have in query in, like how many RUs with this query. And then you can start doing some testing, right? Like I know this query is going to run from my app once in a blue moon or 1,000 times a day. Like let's try to make those like really frequently run queries get the least RUs possible. Like that's the kind of tuning you can do with the offline. A lot of companies and applications use NoSQL, but I would say the most frequently that I have seen are like IoT devices, right? Especially companies manufacturing a lot of different devices coming from the same location. Again, they're collecting sensor data, but every sensor collects slightly different things, right? Temperature, humidity, numbers, defects, like that sort of thing. It's also really good for IoT in terms of, again, that global distribution, the ability to write anywhere, especially if you have manufacturing facilities distributed all across the world and you want to be sending your data into the cloud with the least amount of latency possible. Like it works great for IoT for a couple of things. Retail, again, think catalog, think properties, think trying to manage everything in the Sears catalog. And gaming. There's a lot of online games that just need to throw up player data and app data into a store and really, again, globally distributed. They need lightning fast latency, that kind of thing. Like when you're playing a game, the only person's data that you care about is yours, right? Like generally, or maybe the team. You don't need to know every player's story. So for gaming, that flexible consistency, that write anywhere kind of model, again, works really well for those kinds of scenarios. So NoSQL is by far the most popular API. in the Cosmos family. The others are MongoDB. So MongoDB is a special type of document storage database. It stores BSON, which is binary JSON. So MongoDB, owned by another company, but we partner with them pretty closely. MongoDB in Cosmos DB was really designed to be kind of a lift and shift for customers that wanted to move their app into Azure and also have their MongoDB databases in Azure and not have to run. So pretty close to lift and shift. I've done a couple projects with customers to move into MongoDB in Cosmos, work with your existing tools, work with your existing layer protocol, Mongo shell. That's about all I can say about that. There has been, I'm going to have to update this a little bit more because I did see in some Azure news, there's some buzz coming around MongoDB and Cosmos DB and some of its AI kind of tangential vector embedding things, like there's some things going into preview there. So I'll give this. We also offer a Cassandra, Apache Cassandra API. Cassandra is a wide column data store. So it's a column store on steroids where it takes and breaks. Like every column can be a group of things. What I know about Cassandra is it is a data store that is primarily used when the level of writes far exceeds the level of reads. It's used a lot in certain logging and telemetry applications, used in logistics. It's a database where you throw as much data in as quickly as possible and reads in just a lot less frequently. Which, when we think about it, is kind of the opposite of like OLTP or OLTP databases, where we write stuff once, maybe modify it, and then we read it a ton, like a full with our OLTP and OLAP databases. Cassandra is kind of on the opposite end. So again, this is a third-party product data store that has existed for a long time. Again, they were saying we're moving our app to Azure, in-house offerings. I don't want to spin up virtual machines and still have to manage it. Like you can just have a managed offering. So again, highly compatible with the existing things over the layers. Really designed for lift and shift of existing stores. And table. Who here is using Azure table storage? Okay, yeah, stores key value pairs. Azure table storage is slow as molasses and also is in one way. So all they did when customers started saying, maybe I'm using VR, or maybe I'd like this data that's in East US as a table value to be also available in West US or maybe Europe, they simply moved the Azure table storage layer into Cosmos to take advantage of globally distributed multi-write capabilities. So anything you would use like Azure table storage for, which is again key value pairs, lots of things like more right app cache, shopping carts, again gaming store, that sort of thing, available globally, much better performance than just using Azure. Gremlin. I would say this one is not gotten a lot of love in a long time. It is a graph database, essentially. I have heard at another conference I heard one was this is not even something I heard internally that Microsoft might be working on some other, like partnering with someone else other than Apache and Gremlin. But I think graph databases are cool, right? Graph databases are what power every sort of social media engine, every sort of recommendation engine. You have vertices, so a thing, right? Jes lives in Louisville, which is this thing. And she knows Jeff from the data user group that's in Louisville, the city. And they went to the Azure Meetup group where they met in Anthony, right? So these are all the things are the vertices, how they're connected, their edges. And graph data stories are trying to get you to traverse between multiple objects in the lowest amount of time possible. So recommendations, I had actually a few years ago looked at building a logistics company that was storing everything in SQL Server, and they have literally the most complicated transactional application that I've ever seen in my life. I was trying to move it into a graph service, but because when you think about it, logistics is relationships. I have a package, it was a city. I have a truck, I have a semi, I have a boat, I have a plane. I need to get packaged from city to city. What is the shortest distance between those points? They were solving that problem in SQL Server. It was not, that was what they had built many years earlier. It was not the ideal situation. But that's kind of what graph database engines do, right? Multiple points, how do we get between them as quickly as possible? The Gremlin querying language was one of the weirdest. And then last but not least, Postgres makes another one. So Postgres has an extension called Citus. So for anyone that's ever used SQL Server, right, you have SQL Server, which has one, or Postgres, right? You have your one server that holds all of your data and your one engine and one set of data. You can take that and turn it into an analytics platform. That would be, think about Synapse Analytics, you mentioned that earlier, right? So you have your data, instead of all being stored as one big lump, it's sharded out across multiple worker nodes. And then when a query comes in, you have the head node, the control node that says, okay, I know you want the data. It's going to come from, this is going to come across multiple nodes. If I had all my data in one place, it would take me 2 hours to get this data. But because it's sharded out, I can parallelize the query, we pull that back, bring all the results together, I can run this query in 20 minutes. That's what Citus does. It's just another way of having control node, worker nodes, sharding your data, but it's still totally relational. We use a lot of analytics platforms. Azure used to offer this as a standalone service. So you could get Azure database for Postgres flexible serverless sites, which might actually be the one probably. But then they kind of took a look back and wait, we have a control node and distributed data. And over here we have Cosmos DB, which has a control node and partitioned distributed data. Perhaps if we put Citus on the Cosmos infrastructure, you'd have fewer headaches. And thus, that is why you will see Postgres, Citus, and Cosmos DB. The two are just very different. So it's still Postgres, still the Postgres engine, still the PostgreSQL language, server parameters, some extensions, like the interoperability between Citus extension and all other extensions is not as vast as you would think. Some are hard to interoperate. We don't know about any of the AI stuff with this. But yeah, it's used a lot for analytics, high throughput transactional things, those primarily. So that's a quick walkthrough. The Tesla, right? The Cosmos DB, again, NoSQL API, JSON docs, probably the most okay. So last but not least, the in-memory database, right? Redis. Probably have used this at some time. I consider Redis to be Ducati or motorcycle, but like it is fast. So you can, again, Redis used commonly for caching, right? It is a caching layer. Again, you could spin this up as a virtual machine in Azure and manage and Redis version of that. But you can also get this as a platform as a service also. So there's actually two. There's open source Redis. We offer that as a platform as a service offering with 3 different tiers of service. So basic, standard, and premium. There is also a Redis Enterprise, which offers things like Bloom and time series and JSON. We offer that as a PaaS.
If you want to use vectorization, you have to do that one. And that's why it's so expensive.
Yes. So if you want to do anything fun with Redis beyond just pure caching, right? If you want to do anything more advanced, it's almost inevitably going to be in Redis Enterprise. And they have 2 tiers there, Enterprise and Enterprise Flash, and yes, significantly more expensive. So this is a cache, right? We use this for any data that we need at a very low latency, very messaging queues, job queues, caching on websites, lots of different abilities here. I would say again, like this is Redis, but we're managing the OS, we're managing, you don't have to do that kind of thing. It also very closely integrates with Azure Functions, particularly Azure Function Triggers, which is again another platform of this service offering, and that just makes the work of setting it up a lot less intensive. You basically just connecting to Azure services. Yeah, using Redis as a message. Yeah. All right, so now that's kind of the spin through the major relational, day-to-day transactional database system. Again, not covering analytics, Synapse, Databricks, Fabric, all of that, because I've got another couple of hours having that maybe next year. We'll talk about it again. But let's talk then a little bit about what is managed, right? So this is a platform as a service. Okay? We talk about what you get from it. So for all of these, backups are just built in. Your backups are the foundation of your transactional database system, you know, OLTP. So backups are automatic, built in, cannot be turned off for these systems. Like you can set it to 1 day that you're going to keep the backup. You can do restores, obviously, and these are all going to give you the ability to do point-in-time restores. So somewhere between the last 1 day and 35 days. Most of them also offer geo restores, which means my database is in East US 2. Oh no, East US 2 is down. How do I get my database back? I don't have any other DR set up. Oh, East US 2 is paired with Central US. My backup is in Central US. I can just restore my database from the most recently replicated backup. Cosmos DB does not offer that because Cosmos DB is globally distributed, so you just need to turn on more than one. High availability. So typically when we think about HA, we're talking about same data center on premises or same region within a cloud, AWS, Azure, etc. So that is automatically built in for both Azure SQL and Cosmos DB because those are the ones that Microsoft owns. Right? So that you don't even have to think about it. No matter what you set up within the same data center. For Postgres and MySQL, those both rely on a form of replication to another secondary. You can absolutely set it up. Again, just a couple clicks, like, yes, I would like to make this highly available. I want my replica to have this many cores, and it sets up the replication. Again, having dealt with Postgres replication a couple of times, I can tell you, the DBA, I want to do this in a platform as a service offering where they set it up and manage it for me rather than setting it up to give you the price for it. So then disaster recovery, being able to go through the all of them offer it. So that Azure SQL and Postgres and MySQL, you're going to have, again, backups replicated to other regions. You can also set up just other replicas in other regions and have them available. Read replicas, Cosmos DB scales out worldwide. Redis allows you to set up zone redundancy. So you can't have true like disaster recovery across different regions in Redis. It's in memory, but real hard to shift memory across. You can have your data persistence. But we do offer within an Azure region, right? So East US, think of East US as a region. East US is going to have multiple data centers. Within a region, we set up zones, right? So a data center is 1, 2, and 3 are zone. Data centers 4, 5, and 6 are zone 2. 6, 7, and 8, or 7, 8, and 9 are zone 3. So they might share common power, they might share common like fiber, internet back, but zone 1, zone 2, and zone 3 are all going to have separate power, separate internet, for some level of fault tolerance. So within something like Redis, you can set up zone redundancy. At the very least, it doesn't give you two like different regions, but it gives you redundancy within the same region, guaranteeing you'll at least be on different power networks, different internet networks, like some level of isolation within this. All of the others offer that as well. There is the redundancy available. And then we'll talk about high availability of that. And then version upgrades. Again, that's a big part of being a data administrator. So with, again, Azure SQL and Cosmos DB, because those are the database engines Microsoft owns. Those are always kept up to date. You won't ever have to do another version upgrade again. It's amazing. With Postgres and MySQL, so they're going to have like the 3 versions, right? There's the patch, update, divide, and version. Microsoft takes care of all patch and minor version upgrades. Major version upgrades. You still manage those yourself, but we currently have the ability to do major version upgrades with Postgres automatically in preview, so they are going down that road now, which I think that will be another huge selling point for Postgres on Azure Database flexible. But like again, the point of limited platform is to take some of this administrative burden away from your admin. Right? Not having to set back on things, not having to set resource schedules, not having to set up availability groups in SQL or data replication for high availability in Postgres or MySQL. That is the promise of the platform. So getting started, you can sign up for a free trial. We're at an Azure Meetup group. I'm guessing most of us use Azure day to day. But for anything you're interested in as well, Azure sample GitHub repo has a ton of great, like just about any configuration of application /framework combined with an Azure data service, different retail examples, gaming examples, that sort of thing. And then every documentation group here is going to offer quick starts, templates, get started guides, just different walkthroughs. And with that, I will leave it with my contact info, take questions, feedback. So quick, and you can walk through about 6 different database systems at a very high level. Okay, questions, discussion, thoughts? Okay. So Azure search for Kafka will know SQL
It provides additional indexing. Careful, because you can scale it in 2 directions. As that cost goes, it's happened to me once. You scale it in 2 directions. One of my developers scaled it in both directions. And it was a very expensive lesson. I had to learn about, making sure that didn't happen again.
Did Microsoft forgive that?
Yeah,
Okay.
they ended up forgiving it, but I split it off for about 2 weeks.
I only for in Cosmos by itself was like that because we were building a global application, and I'm like, we can make it fast everywhere. And we did. We did. It was super fast everywhere. Yes.
And expensive everywhere.
It was very expensive. Also forgiving.
So there's like the number one thing Azure what is your other policy for that? Like, because sometimes you can set max number of this to scale out to, max number of that to scale out to, max number of regions you can be in. So just yes, when testing something new, like also make it a point to kind of check out the policies for it and enable those at the resource group or subscription level.
Policies have grown dramatically in the last 15 months.
Yes.
Prior to that, they were pretty minimal.
Very cool. Well, thanks for coming.
Thank you. Yeah.
Questions. I'm always, so a couple of other things I would like to say. So I co-run the Louisville data unit. So it used to be the SQL Server group, but have expanded much more. We now have talks about Postgres and Database and Snow and other things throughout the year. So again, we also meet the second Thursday of the month, but we meet at lunch. So if you ever meet a group again, if you have data people, your company, but please let them know. We are looking again, like you guys are restarting looking to grow. We restarted like a year and a half ago, and are slowly getting some new members. Like we've got that core people that were there before, or things that we're slowly starting to meet new people to learn, like the whole thing out.
Focused on databases or?
Data topics in
There used to be a predictive analytics meetup that kind of petered out back when it was, about 5 years ago, it was being run over at Bellon.
I mean, it's just so awesome that like so many times we'd be like, let's see what this communication was. Something along the path we'd be like, oh, we didn't have the concert.
Good fight is footing. Good fight is footing.
we had some areas.
Exactly.
So weird, like,
Yeah, right.
like thing. And then, I know it was kind of. All of that, there's no ML. That's Louisville.
Okay.
Louisville.
Eating gets drinks. If anybody wants to join, we don't really have a place that,
You go to Shade, where we go a lot.
And everybody, thank you if you're online. Thanks for joining.
A couple of,
I think when we go tonight, we can sit outside.
the native was this morning, this weather.
Yes,
Get 'em on